representing proportional relationships with tables. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. Proportional relationships in a table. So we're going to complete this table, finding a pattern for the number of hours and the amount earned. We have 1 hour, and we've earned $12. So now we know that we're going to earn $12 per hour. So $12 per hour. So $2, we earn $24. Okay, that sticks with our $12. Our first blank is at $60. So at $60, we need to find out how many times 12 is going into 60 in order to find out how many hours it is. So if I know 2 times 12 is 24, because that's right here, I can try 2, 4, 5 times that. Let's try 5. So 12 times 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. So 60. So 12 goes into 60 5 times. So to earn $60, I have to work 5 hours. Our next blank is for 8 hours. If I know I earned $12 an hour, and I worked 8 hours, we're going to multiply 8 times 12. So 2 times 8 is 16. Carry the 1. 8 times 1 is 8. Plus 1 is 9. 96. $96 to work 8 hours. And our last one is $144. So we're going to divide 144 by 12. 12 goes into 14 once. 14 minus 12 is 2. Bring down our 4. And we know that 12 goes into 24 2 times because once again it's right over here. So 2. So 12 hours will get us $144. So we've completed our table. And as we go up, the number of hours is going to be multiplied by the amount earned per hour. So with our 8, we got $8, 8 hours, $12 an hour, $96. So what is the relationship between the number of hours and the amount earned? Well, the relationship is going to be the number of hours times 12. So, number of hours times 12, or our dollars per hour. Now, for each column that we've completed on our table, we're going to write the ratios for the amount earned to the number of hours. Now, because it says amount earned first, that's the first number when we write our ratios here. So we have a 12 to 1, 24 to 2, 60 to 5. 96 to 8. And 144 to 12. And that's how we would put this table into a ratio, each of the columns. A proportional relationship can be described by an equation. So instead of writing it in our ratios like we just did, we can write it as an equation or as something that can be solved. And this right here, y equals kx, is going to be the formula that you would use to write it as an equation, where k is called the constant. So this will never change in the equation. That will be a number that's always going to be the same. So it's called the constant of proportionality. Finding the constant of proportionality of a proportional relationship. All right, so this table, we have pounds and ounces. So for every 3 pounds, we have 48 ounces, 4 pounds, 64 ounces, and so on. We're going to let x, we're looking at x from our equation, represent pounds. So I'm going to put an x right here. And y is going to be ounces. So there's our y. We're going to write a ratio for each column for ounces to pounds. Ounces first, so 48 ounces to 3 pounds. And 64 ounces to 4 pounds. 96 ounces to 6 pounds. 112 ounces to 7 pounds. And 160 ounces to 10 pounds. Now we're going to use the ratio as the constant of proportionality in the equation y equals kx. So to use the ratio, a ratio is actually a fraction waiting to be. So if I were going to, I am going to use this one. So first of all, if I were to write 64 to 4 as a fraction, because it's easier to use it in an equation, we would write 64 to 4 equals k, or our constant of proportionality. So I'm going to use that for my constant, and I can pick any of the other pairs. This one, this one, this one. I'm going to circle that one better. Or this one for my equation. Let's use this one. I'm going to change the color so you can see which one I'm pointing at. Let's use this one. All right. So, where's my y in this one? Well, let's see. Here's y. And I'm using the 12. So, 1, 1, 2 equals 64 over 4. And where's my x? 7. Okay. And this is going to be times 7. And this is the same format as y equals k x. Now, it's in the format. Did it tell us to solve the equation? Nope. So we're not going to. We're just going to leave it. This is as far as we need to go with this one. Now we're going to try it ourselves. 15 bicycles are produced each hour at the Speedy Bike Works. Make a table to show the relationship between hours and bicycles produced. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship. And then we're going to write an equation for the relationship. So, we're going to make a table first. And hours. Bikes. And for 1 hour, it's going to be 15 bikes. Let's just do 2 hours, 3 hours, 4 hours, 5 hours, 10, and 12. So for every 1 hour, we have 15 bikes. So to fill in this next box, we do 2 times 15, which is 30. This next one is 15 times 3. Oops. Let's fix that 3 and make it pretty. Fifteen times 3. 3 times 5 is 15. 3 times 1 is 3. 45. Now we have 15 times 4. 5 times 4 is 20. 4 times 1 is 4, plus 2 gives us 60. And 5 times 15 times 5. 5 times 5 is 25. Carry our 2. 5 times 1. Oh, that's the bell. 5 times 1 is 5, plus 2, 7. 75. 15 times 10 is 0, 0, 5, 1, 150, and 15 times 12. 2 times 5 is 10. Carry the 1. 2 times 1 is 2. Plus 1 is 3. 5 times 1 is 5. 1 times 1 is 1. 180. All right. So, we made our table. We have to make sure we know where we are in this story because it's easy to get lost in word problems. Now we're going to show the relationship between the number of bikes produced and the number of hours as a proportional relationship. So, if I want to write it as a ratio, I can write it as a 30 to 2 or 15 to 1. Because remember, this is our y and this is our x. Okay? So, now that I've written it as a proportion, this equals 15 over 1 and 30 over 2. All right. So I have shown that we have a proportional relationship because if I have 15 to 1 and 30 to 2, I can make, those are equivalent fractions. Now we're going to write our equation for the relationship. So we can use this as our K, which is our proportional relationship. Okay? Remember, our equation is y equals kx. So we're going to pick one of the y's. Remember, this is the y, which is the number of bikes. Let's say 60 equals. And for k, we're going to use 15 to 1. And our x is going to be 4 because 60 and 4 are a pair in our table. So we wrote it as a proportional relationship, and then we wrote our equation. Okay, so that is all we had to do. Once again, we don't have to solve it. It's learning the format, and that's our format.